Hello everyone, welcome back to my channel. So in this video we are going to learn about linear polarization. Linear polarization. Okay, so its characteristics and why we are calling this as linear polarization, and how can you justify that it is a straight line. Okay, so all this concept we are going to learn in this video. If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so what is linear polarization? As I have told you, polarization in my previous video, it is the orientation of electric field, okay, as a function of time at a given particular location. So if the orientation is a straight line, then it is called as linear polarization. And again, linear polarization is classified into two types. One is vertical polarization, right, and second is horizontal polarization. Okay, so horizontal polarization. Right, we'll see now what is linear polarization. So first of all, we'll write the equation for electric field. So if you have electric field traveling along plus z direction, so if you have a wave traveling along plus z direction and it has both the x and y components, okay, so I have told you how to write the wave equation also. So if the wave is traveling along plus z direction, so how can we write the wave equations? So it will be Ex naught into e power alpha z cos of omega t minus beta z into ax cap plus e y naught into e power minus alpha z into cos of omega t minus beta z into ay cap. So this is x component, that is component of electric field intensity along x direction. So this is y component along y direction. So electric field intensity along y direction. So this value Ex naught into e power alpha z, I am considering it as Ex dash. So Ex dash is equal to Ex naught into e power minus alpha z. So this is amplitude of electric field intensity along x direction. Yes, so no, so it is amplitude of electric field intensity along x direction. Similarly, this term is, I am considering it as Ey dash. Ey dash is Ey naught into e power minus alpha z. So this is amplitude of electric field intensity along y direction. Okay, so if you have Ex dash and Ey dash, now we can define linear polarization. Okay, so in linear polarization, very important point. So this is how we will classify. So in linear polarization, amplitudes of Ex and Ey, that is amplitudes of the electric field intensity along x and y directions, that is Ex dash is the amplitude along x direction and Ey dash is the amplitude along y direction. So in linear polarization, amplitudes of Ex and Ey, that is Ex dash and Ey dash. Okay, so maybe either equal or unequal. Okay, so they may either be equal or unequal, but they must be in phase. They must be in phase. Okay, so this is the condition for linear polarization. In linear polarization, amplitudes of Ex and Ey, that is Ex dash and Ey dash, may be or may not be equal, but they must be in phase. That is, the angle between them must be equal to 0. So Ex dash is equal to Ey dash, or Ex dash may not be equal to Ey dash. So both conditions can be there, but angle between them, that is the phi, phase difference between them, must be equal to 0 degrees, so that they must be in phase. Okay, so this is the condition for linear polarization. So linearly polarized waves, this is also one of the important point, please remember, linearly polarized waves are produced by simple antennas. So for example, dipole antenna, simple antennas like dipole antennas, and lasers. So the optical signal which is coming out of laser is also a linearly polarized wave. Okay, so just remember these important points and this concept. In linear polarization, amplitudes of Ex and Ey may or may not be equal, but they must be in phase. Okay, so let me take one more slide. I'll explain you very clearly how the orientation is a straight line in the case of linear polarization. Okay, so we have E bar of z comma t as Ex naught into e power minus alpha z cos of omega t minus beta z into ax cap plus Ey naught into e power minus alpha z into cos of omega t minus beta z into ay cap. Okay, so for simplicity, let us consider z is equal to 0 plane. Okay, so in order to show this orientation, I am considering z is equal to 0 plane. So when z is equal to 0, then E bar of 0 comma t will becomes now e power x naught. So z is equal to 0, so z is equal to 0, this term becomes 1, e power 0. So e power 0, which is equal to 1. So it will be cos of omega t, again beta z, so that is equal to 0, 0 into beta is also equal to 0, ax cap, right, plus Ey naught into cos omega t ay cap. Okay, so this is the wave equation, right, in linear polarization. So Ex naught cos omega t, Ey naught cos omega t, right. So when omega t is equal to 0, we'll write cos at different angles, right. So when omega t is equal to 0, so then what will be the equation for E naught? So E naught is Ex naught, so cos 0 is 1. Okay, so Ex naught ax cap plus Ey naught ay cap. Okay, so the point here is Ex naught comma Ey naught. Okay, similarly omega t is equal to 45 degrees. So when omega t is equal to 45 degrees, so E bar is Ex naught by root 2 x cap plus Ey naught by root 2 ay cap. So the point here is Ex naught by root 2, similarly Ey naught by root 2. Okay, so we'll write for all other angles, right. Omega t is equal to 90 degrees, so cos 90 is 0. So the point here will be 0 comma 0. So when omega t is equal to 135 degrees, okay, so cos 90 plus 35, which is minus sign. So minus sign is minus 45. So minus sign 45, 1 by root 2. So this will be minus Ex naught by root 2 minus Ey naught by root 2. Right, so when omega t is equal to 180 degrees, so cos 180 is minus 1, so it will be minus Ex naught minus Ey naught. So minus Ex naught into Ax cap minus Ey naught into Ay cap. So the point of intersection will be Ex naught and minus Ax naught and minus Ey naught. Similarly, when omega t is equal to 225 degrees, so 225 degrees, the point of intersection will be minus Ex naught by root 2 minus Ey naught by root 2. Okay, so cos 225 is minus 1 by root 2. Similarly, when omega t is 270, omega t is cos 270 is 0, cos 180 plus 90 degrees, so it will be cos 90 degrees, which is equal to 0. So it will be 0 comma 0 again. And omega t is equal to 315 degrees. Okay, so it will be Ex naught by root 2 Ey naught by root 2. When omega t is equal to 360 degrees, cos 2 pi value is 1, so it will be Ex naught Ey naught again. Okay, so Ex naught and Ey naught again. So I am drawing these points on a plane. So I am taking a plane here, right? So I am drawing here. So this is Ax cap, that is x axis, and this is Ay cap, that is y axis. Okay, because the E bar is in terms of Ax cap and Ay cap. Right, so first point, omega t is equal to 0, Ex naught and Ey naught. So somewhere Ex naught, so this is 0 comma 0, this is origin 0 comma 0, and we have Ex naught by root 2, and this is Ex naught I am taking, and we have Ey naught by root 2, and this is Ey naught I am taking. So if this is Ex naught by root 2, so this will be minus Ex naught by root 2, right? So this will be minus Ex naught. Similarly, here it will be minus Ey naught by root 2, so here it will be minus Ey naught. Okay, because these are the possible points which we have getting. So what is the first point? Ex naught and Ey naught, Ex naught comma Ey naught. So Ex naught Ey naught intersection. So this is the point. So this is where we have to draw. So I am representing the points with a cross mark. Right, next, omega t is equal to 45 degrees. It will be Ex naught by root 2 Ey naught by root 2. So Ex naught by root 2 Ey naught by root 2. And next 0 comma 0, so this is the point. Next, Ex naught minus Ex naught by root 2 minus Ey naught by root 2, so minus Ex naught by root 2 minus Ey naught by root 2, so the point of intersection will be here. This is Ex naught by root, sorry, this is Ex naught by root 2, so in this direction, and this is Ey naught by root 2, and again minus Ex naught minus Ey naught, so point will be this. Next, minus Ex naught by root 2 minus Ey naught by root 2, so already we have taken here. 0 comma 0 already we have taken here, and Ex naught by root 2 Ey naught by root 2, so this is the point. So for the second time you are getting same, and Ex naught by root 2 Ex naught Ey naught, so this is the point. So if you join all the locus of those points, if you join the locus of all those points, so what you are getting? You are getting a straight line. You are getting a straight line, and hence it is a linear polarization, and hence this is linear polarization. So why you are getting this? Because there is no phase shift, because both the terms represents cos omega t only. Okay, so both the terms represents cos omega t only, so that's why you are getting the linear, that is the locus of all the points at different angles. If you take, so the locus of all those points is now a straight line. So locus is a straight line, therefore that concept or that type of polarization, that type of orientation is called as linear polarization. Okay, so if Ey naught is equal to 0, if Ey naught is equal to 0, then what will happen? You will have only Ex naught terms. right? So for the first omega t is equal to 0, what is the point? So first point will be ex0 comma 0 for omega t is equal to 0 degrees. I am not writing again, okay, I'll just write the points here. So ex0 comma 0. What will be the second point? For omega t is equal to 45, ey0 is 0, so this term is 0, so you'll get second as ex0 by root 2 comma 0. Yes or no? So ex0 by root 2 comma 0, right? So if you substitute 135, so 90, suppose 90, if you substitute, you'll get 0 comma 0. Next, if you substitute 135, we'll get minus ex0 by root 2 comma 0. Next 180, if you substitute, it will be minus ex0 comma 0, because ey0 is equal to 0. Only change is ey0 is equal to 0, and x terms as it is you will get. So next is minus ex0 by root 2 comma 0. So next is 0 comma 0. Next for 315 it will be ex0 by root 2 comma 0, and last you'll have ex0 comma 0. So if you plot on the graph, same graph I am taking, this is ax cap and this is ay cap, okay, so same I am taking. So if you plot on this, so this is 0 comma 0 at origin, so this is ex0 by root 2, this is ex0, so here it will be ex0, so here it will be minus ex0 by root 2, and here it will be minus ex0. So if you plot this point ex0 comma 0, so ex0 comma 0 will be on x-axis. Yes or no? Right. So next is ex0 by root 2, so this is the plot. 0 comma 0, so this is the plot, and again minus ex0 by root 2, so this is the plot, this is the point, sorry, minus ex0 comma 0, so this is the point, right, on the x plane only, on the x-axis only, because the point of y is equal to 0, and again reverse, so minus ex0 by root 2, this is the point, 0 comma 0, this is the point, ex0 by root 2 comma 0, this is the point, and ex0 comma 0, this is the point. So if you join all those, so it will be a horizontal line. Okay, so this is also a straight line, but it is oriented horizontally, so that is why this polarization is called as horizontal polarization. Okay, so this is the special case of linear polarization, that is first type of linear polarization. Linear polarization will be a straight line, and if it is oriented horizontally, then it is called as horizontal polarization. Okay, so this is obtained by substituting ey0, that is y component is equal to 0. Similarly, if you substitute x component is equal to 0, ex0 is equal to 0, you will get vertical polarization. So you'll get vertical polarization. So this is ax cap, this is ay cap. Yes or no? So different points will be, so this is ey0 by root 2, this is ey0. Okay, so this is 0 comma 0, so this is 0 comma 0. So this will be minus ey0 by root 2, minus ey0 by root 2, so this is minus ey0. Okay, so if you plot the points, you will get the points here only. Okay, so if you want to check, you can check also. So you'll get a straight line in vertical direction. So this polarization is called as vertical polarization. Okay, so this is how we can classify, and this is how we can justify that if there is a phase shift of 0 degrees, that is the x component and y component amplitudes, sorry, phase difference is 0, that is phase is the x component and y component are in phase, then we can say that it is having a linear polarization, that is the orientation is along the straight line. So that is wave will travel in this direction only, in straight lines, so like this. So wave will travel in this, along this straight line only. Okay, so this is called as linear polarization. And if y component is 0, you'll get horizontal polarization, and if x component is 0, you'll get vertical polarization. Okay.